John Dalton was an English chemist, meteorologist, and physicist. He is best known for his pioneering work in the development of the modern atomic theory.
J.J. Thomson was an English physicist and discovered the electron in 1897 by the plum pudding model.
Niels Hendrik David Bohr was a Danish physicist who made great contributions to understanding atomic structure and quantum mechanics. In fact, he received the Nobel Prize in Physics in 1922.
Ernest Rutherford was a New Zealand chemist who helped pioneer nuclear physics. Rutherford won a Nobel Prize in 1908 for his efforts in chemistry.
John Dalton came up with his own atomic theory, which stated 1. All matter is composed of small particles called atoms. 2. All atoms of a given element are alike. 3. Compounds are formed when different atoms combine in fixed proportions. 4. A chemical reaction involves the rearrangement of atoms. The modern atomic theory is, of course, a little more involved than Dalton's theory, but the idea of Dalton's theory remains accurate. Today we know that atoms can be destroyed via nuclear reactions, but not by chemical reactions. Also, there are different kinds of atoms differing by their masses. Within elements, these are known as isotopes, but isotopes of an element have the same chemical properties.
J.J. Thomson discovered the electron in 1897 in the plum pudding model. The plum pudding model of the atom was made after the discovery of the electron, but before the discovery of the proton or neutron. The atom is viewed as electrons that surround by a soup of positive charges, like plums surrounded by pudding. During the plum pudding experiment, J.J. Thomson discovered that electrons were negatively charged particles. He used cathodes, which are negatively charged electrodes. I remember this because it has the word cat in it. I hate cats. And then anode is the opposite of a cathode, so it's positively charged.
The Bohr model shows the electrons in atoms are in orbits of differing energy around the nucleus. Think of planets orbiting the sun. Bohr used the term energy levels or shells to describe these orbits. He said that the energy of an electron is quantized, meaning electrons can have one energy level or another, but nothing in between. The energy level an electron normally occupies is called ground state, which is right here where the electron's at. But it can move to a higher energy, less stable level or shell by absorbing energy. And as it absorbs the energy, it moves up to excited state. This higher energy, less stable state is called the electron's excited state. After it is done being excited, the electron can return back to its original ground state, back to here, from here, by releasing the energy it has absorbed as shown in the diagram above.
The gold foil experiment was a series of tests in which positively charged alpha particles, helium nuclei, were fired at a very thin sheet of gold foil. If Thomson's plum pudding model was correct, the big alpha particles should not have passed through the gold foil with only a few minor deflections. In the gold foil experiment, Ernest Rutherford discovered that J.J. Thomson's model was incorrect because the electrons are not inside the atom. Instead, they orbit the nucleus like planets orbiting the sun. He also discovered that the atom is mostly made up of space, which is why particles don't collide.
Hey, Macklemore, can we go thrift shopping?
What?